So here we are with the common AP question in the free response. Remember, this year you guys are getting extra free response questions, or really just 2 free response questions, and that's the test. So that's going to be a big deal to, make sure we can get these free response questions down. So let's look at this. When we have the graph of the continuous function g is the derivative of the function f is shown above. So in other words, if you have f prime is g. So they're giving us basically the graph of f prime. That's another way to think about it. And the function g is piecewise linear, -5 to -3, or -5 to 3. So just see that it's just basically it's piecewise, broken into pieces, and it's all lines, all the way from -5 here to 3. And then g of x is 2 times x minus 4 squared. That's just a parabola shifted to the right 4 from 3 to 6. So from there on, it's a parabola. So let's look at the first question. So we have that f of 1 equals 3. What's the value of f of -5? So how are we going to find that? So let's look at this. And I know we talked about that in some other videos, so we do need to know how to do this. So if f of 1 equals 3, we need to find f of -5. And I really want to go through this in the AP rubric as well. So as we get through this, I want to show you how the points are awarded in here. So f of 1 equals 3, find f of -5. And they really just gave us the graph of f prime. So what are we going to do? We're going to use that fundamental theorem of calculus, the fact that the integral of f prime of x from a to b is equivalent to f of b minus f of a. So what I'm going to go ahead and do is I'm going to use this. I'm going to let's call b 1. Look at those x values. 1 we'll use for b, and then -5 we'll use for a, just because that's the lower bound, upper bound here. So I'm going to go ahead and use that, and instead I'm going to call this g of x. Why not? I mean, that's what they're calling it. So instead of f prime, we're just calling it g of x. You can think of it, though it is f prime. It's the same thing. And we're going from -5 to 1. And that equals, that would equal f of 1 minus f of -5. And what is f of 1? Well, f of 1 is given. F of 1 is 3. So I'm going to go ahead and substitute in a 3 for my f of 1. So f of 1 is 3, so I put the 3 in there. Then we have minus f of -5. That's what we need to find. And then we're going to go ahead, what are we going to do for this right here? Well, this right here, and let me just highlight it one time around in a circle there. So that there is just the area under the curve from -5 to 1. So we just need to figure out what's this area and that area. We're just going to go ahead and find that area underneath the curve, and that's going to be our integral. So from -5 to 1. So we have, let me just zoom in. So we have this section, and that's a 3 by 3 square. So that area is -9. And then we have this triangle. So that's 1/2 base times height. So 1/2, our base is 1 times our height is 3. So that's -3/2. And then over here, this triangle, I didn't erase that space, so we're looking at this triangle now. And that's a 1 by 2 triangle, so 1/2, 1 times 2 is just 1. So our area of our triangle, or not our triangle, our area of our space there is going to be -9 minus 3/2 plus 1. And then we're just going to go ahead and solve for f of -5, and that's going to answer that question. So here we're going to get, let me think real quick, -9, so that's going to be, I need to get a common denominator, so that's -18/2 minus 3/2 plus 2/2 equals 3 minus f of -5. And then that's going to be -21 plus 2 is -19/2 equals 3 minus f of -5. Subtract the 3, so -19/2 minus 6/2. I'm just going to go ahead and get that common denominator right now. And then that's going to be -25/2 equals negative f of negative 5. So then what would your final answer be? Well, we got to divide that negative to the other side. So basically 25 over 2 is f of negative 5. So how is this broken down? Right here, 1 point for the answer. And then over here, they just want, this is 1 point for the integral. And that's how that's broken down. Let me just lasso this and put this somewhere else for now. And we'll go ahead and I'm going to go ahead and erase this and we'll look at part B. So for part B, we need to evaluate the integral from 1 to 6 of g of x dx. And we basically have already done this. So we need to find the area under the curve from 1 to 6. So we're going to go ahead and let's section that off. So 1 to 3 is this nice square. It's a 2 by 2 square, so that's 4, and it's a positive area because it's above the curve. And then how are we going to do 3 to 6? So basically what I'm going to do is I'm going to split this up. I'm going to split this up, and I'm going to say we're going to integrate this from 1 to 3. And then I'm going to split this off to 3 to 6. And we know that integral from 1 to 3 is 4. I'll go ahead and substitute that in. Plus, we got to integrate from 3 to 6. And what are we going to use for that? Well, we have the function 2 times x minus 4 squared dx. So let's go ahead and just evaluate that. So that's going to be 4 plus 2 times the integral from 3 to 6 of x minus 4 squared dx. Let's use a u substitution on that. So u is going to equal x minus 4. du equals 1 dx. So then du equals dx. So it's a really easy u substitution. I'm going to change the bounds. So we're going to have plus 2 integral from negative 1 to 2 u squared. And then don't forget about that 4 out front there. And then this is going to equal 4 plus 2u cubed over 3 from negative 1 to 2. And that's going to equal 4 plus 2 times 2 cubed over 3. I'll put parentheses just to show that I'm evaluating this right here. Minus 2 times negative 1 cubed over 3. So that's going to equal 4 plus, and that's going to be 16 over 3. Minus, actually that's going to become plus because we have all those negatives there. The negative 1 cubed is negative 1 times negative 2 is positive 2 over 3. And then that's going to equal 4 plus 18 over 3, which 4 is 12 over 3, isn't it? So we might as well just get our common denominator. And 12 over 3 plus 18 over 3 is going to be 30 over 3. And all that work to get the answer of 10. So there you have it. How is this broken down? This is a 3-point problem now. So this is 1 point for the answer. My arrows are looking really bad. And then another one for the antiderivative. Yeah, it was really bad handwriting. I'm sorry, guys. And then another point just for the split. So you did need to split that off and show that. So that's part B. Let me just put this somewhere else. And let's look at part C. So part C, on what open intervals, if any, is the graph of f both increasing and concave up? So we want to look for where is f increasing. So this is the graph of f prime. We're talking about this in the above video. So when is f increasing? Well, if f prime is positive. So where is that? Well, when it's above, here's the x-axis, when it's above the x-axis. So that's only right here. So if f prime is positive, if you remember from above, then that means that f is increasing. And notice right here, really important, they want us to give reason for the answer. So let's just put this over here, and we're going to call this part C. So I'm just kind of writing a quick justification. And then now we need to think about when is it concave up? So f double prime, if it's positive, then that means that f prime is increasing, and that would mean that f is concave up. So we're looking for both of these things. So we're looking for when is it positive? When's the derivative positive? Well, that's right here because that's when f is increasing. When is it concave up? Well, that's when the second derivative is positive. In other words, when f prime is increasing. So we're looking for when is this graph positive, which is right here, highlighted in green, and when is it increasing? So let me highlight where it's increasing. Well, that'd be right here and right here. So from 0 to 1, and usually we like to give this notation. It's a little better notation for your intervals. So x is between 0 and 1. And hang on, we need to write a little statement here. So the graph of f is both increasing. Don't put INC, put increasing. And concave up. On the intervals 0 to 1, or x is between 0 and 1, and 4 to 6. And what's the reason? Well, the reason's actually really simple. Because f prime is positive, and f double prime is positive on those intervals. You don't really have to explain it's because the graph is above the x-axis. You don't have to explain that it's the graph is increasing. It's just simply you say f prime is positive or f double prime is positive. It does help to mention g. You could say that f prime, which equals g, is positive. That also would help. But right here, 1 point for the intervals. One point for the reasoning. And the reasoning is that simple, honestly. So don't get too carried away with your reasoning. Let me move that over here. We'll bring it back later. Last question here. Find the x-coordinate of each point of inflection of the graph of f. Explain your answer. So what is a point of inflection? Well, point of inflection, and on your AP test, don't put POI. Just point of inflection is where f changes concavity. Now we don't have the graph of f here. Instead, we have the graph of f prime. So think about it. When is concavity changing? Well, when this graph is going from increasing to decreasing. Because think about it. F double prime is positive means that f prime is increasing. That means that f is concave up. And when f double prime is negative, that tells us that f prime is decreasing, which tells us that f is concave down. So we're really looking right here. When is f prime increasing and changing from increasing to decreasing? When is that change being made? That's when our concavity is changing, and that's where our points of inflection are at. So right here, we're really looking, and it's going right here. So we don't have any concavity here because we're not increasing or decreasing. Right here we're increasing, but this isn't really changing from increasing to decreasing at the spot, because increasing and then it's 0 again, then it's increasing and it's 0 again. So these aren't points of inflection because the concavity truly didn't change. Right here is also not a point of inflection, but at this point, because it's going from 0 to decreasing, the only point of inflection, we really want it to be changing from positive to negative. The only time that really happens is at x equals 4, because it's going from decreasing to increasing. So your answer would be, here's your answer. The graph of f has a point of inflection at x equals 4 because f prime changes from decreasing to increasing at x equals 4. So you could say that means that f double prime changes from negative to positive. That would be a good explanation, but it really isn't necessary, right? There's enough information right there. It's just saying that f prime, and you could say f prime of x, be a little more formal with that if you want to. So f prime of x is changing from decreasing to increasing is enough information. It's still answering it based upon this justification right here, which is the same thing as that. So this would be enough of an answer. And by the way, so it's 1 point for the answer and 1 point for the reason. So you can see how the points are broken down in this. I really hope this video helps. This right here is the problem you guys are going to be working on. And it's pretty similar. Letter D, just kind of be careful with that. You can ask me questions on that on Remind or tutoring or anything like that later on. So just let me know. And anyways, hopefully this helps.